Good morning, students. Today we are back to the mechanism of polymerization, which is unit 3 for the engineering chemistry of textile technologists. This unit, it particularly deals with the types of polymerization, which includes addition, condensation and copolymerization reactions. This addition polymerization reaction, it follows free radical, cationic and anionic mechanisms. We are going to discuss all these three mechanisms in addition to Ziegler-Natta polymerization reactions. Let us go to the first session of Unit 3, which has the general objective to understand and compare the three types of polymerization reactions, which is addition, condensation and copolymerization reaction. To reach this general objective, we are going to study addition, condensation and copolymerization reactions with examples. And a second specific objective is to differentiate two of these polymerization, addition and condensation, where we differentiate and compare how these two polymerization processes occur. Going to the class, types of polymerization. Polymerization reactions. In the last class, we saw monomers, they undergo polymerization processes to form several polymers. And this polymerization process, it may take place through three different types. One is addition, otherwise known as chain growth. Second is condensation, otherwise known as step growth. And the third one is copolymerization reaction. First, let us see how this addition or chain growth polymerization takes place. Monomers having multiple bonds, particularly double or triple bonds, undergo this type of addition polymerization. Monomers combine to give polymers through addition reaction and no other byproduct will be formed. That is, there will be no elimination of simple molecules or small molecules like water, ammonia, etc. during this process, during addition polymerization process. Therefore, here the molecular weight of the polymer will be an integral multiple of the molecular weight of the monomer. You can see there is no elimination of simple molecule. Therefore, essentially the molecular weight will be an integral multiple of the polymer. And second is, next is the number of monomeric unit. Here it decreases steadily throughout the reactions because the monomer add to the polymer one at a time here. The first monomer will be formed, then the second monomer will add to the first monomer and so on. Therefore, one monomer will be added at a time. Therefore, monomeric unit will decrease steadily throughout the polymerization process here. High molecular weight polymers are formed at once because if a longer reaction time is there, it gives high yield. So these are the characteristics of addition or chain growth polymerization. One example is polymerization of ethylene. This is a commonly polyethylene. We use it in the form of bags and everything. So polyethylene is a very important polymer. Two types of polyethylene are available nowadays, LDPE and HDPE. Low density polyethylene and high density polyethylene are available nowadays. So this is one case of low density polyethylene. We take ethylene, which is the monomer here. N molecule of this monomer having multiple bond, that is a double bond, is taken and it is allowed to polymerize in the presence of a catalyst such as acetyl peroxide, benzoyl peroxide. All these catalysts can be used to initiate or to produce a free radical. It can proceed via three mechanisms which we'll see later on. So benzoyl peroxide or acetyl peroxide can be used as an initiator or a catalyst to start the reaction, and here what happens is it breaks the double bond and forms CH2 double bonds, a single bond CH2 twice, which is a bifunctional species. So you can see here bifunctional species is formed. You need not form, there are presence of N molecules here. So bifunctional species is formed first, followed by the formation of polyethylene. N molecules of the monomer ethylene is taken, which results in the formation of polymer, which is a polyethylene, and the intermediate is the formation of a bifunctional species. This indicates one monomer is added at a time. Let us see the second example, polymerization of styrene. Can you write the structure of styrene? N molecules of, this is also a vinyl monomer. So you can see one of the hydrogen from ethylene, it is replaced by C6H5. So this is what we call as styrene. This styrene monomer, it polymerizes. Initially it forms a bifunctional species, which we can write it like this, CH2 single bond, that is shift of electrons, CH, C6H5 twice. Bifunctional species is formed, which again polymerizes. You have N molecules of styrene here. Therefore, C6H5 N times, which is nothing but polystyrene, which is a polymer. These reactions are very simple. Whenever there is addition reaction taking place, you can see the polymer is an integral multiple of the monomer that you have taken. In both in the case of ethylene, where it forms polyethylene, and polystyrene formed from styrene. So here the monomer and the polymer are just the integral multiple. Third, can you write the reaction for vinyl chloride? This is the third example that I am giving you for the polymerization process through addition reaction. We are taking vinyl chloride. Write the bifunctional species as well as polyvinyl chloride. I give you 1 minute for that. Let me write the product for you. The bifunctional species is formed like this, and this is the polymer. N molecules. So this is the nothing but a repeat unit, which we saw in the last class. So the repeat unit. So it depends whether the polymer is a high molecular weight polymer or a low molecular weight polymer. It depends upon the number of repeat units that is formed. And this number of repeat units or everything, it is dependent on the conditions that you are taking for the polymerization process. So this is about addition polymerization reaction. Let us now move on to the second type of polymerization, which is nothing but condensation polymerization reaction. So condensation, as the name indicates, something condenses. Two different monomer molecules will condense. Two different monomer molecules will condense. They may be having a similar functional group or a different functional group. That doesn't matter. But two different monomer unit with same or different functional group will condense in a stepwise manner. That is very important here. In a stepwise manner to form polymers. In a condensation or stepwise polymerization process, monomer having same or different type of functional group undergo condensation polymerization reaction. The polymerization here proceeds in a stepwise reaction between reactive functional group. So, you have a stepwise polymerization processes between a reactive functional groups. Therefore, small molecules such as water, ammonia are eliminated during the polymerization process. During polymerization, any two functional group react to produce the polymer. Therefore, the monomers will disappear early in the reaction here. However, molecules of varying molecular weight are formed at the intermediate stage. Here. So, in condensation, we have molecules that is formed at the intermediate stage. Different molecular weight polymers are formed at the intermediate stage of the reaction. So, this is very essential for a condensation polymerization reaction, and the longer the reaction time here, high molecular weight will be formed. So, the yield in a addition or step growth polymerization, we saw that our longer reaction time will give higher yield. Whereas, here what happens is, when longer the reaction time, then the molecular weight of the polymer will be formed, will be of high in nature. So, this is a condensation polymerization reaction. So, summing up, the polymerization proceeds by a stepwise reaction between two different reactive functional groups here, and two different elimination of small molecules will take place in a stepwise or condensation polymerization reaction, and molecules of varying molecular weight are formed here. So, these are the criteria for a condensation polymerization. Now, let us go to study an example of condensation polymerization reaction. First example that we are going to see is polyamide, which is formed by the condensation between a diamine and a dicarboxylic acid. As you see the structure, you have diamine, amine group 1 and amine group 2. Diamine, and this R may be of anything, CH2 4 times, 6 times, it depends. In the case of nylon formation, it is hexamethylene diamine, where R is CH2 6 times. This is hexamethylene diamine in the formation of nylon 6,6. So, diamine can be taken. This reacts with dicarboxylic acid, where you have COO2 COOH groups attached to again dicarboxylic acid. In the case of nylon, it is CH2 4 times. Okay. So, here diamine and dicarboxylic acid, it condenses where H, one of the hydrogen group, and one of the OH groups. You can see different functional groups here. These two react to condense. An elimination of simple molecule, here it is water. Water gets eliminated to form the product. So, this is the polymerization product, which is nothing but polyamide. A polyamide is formed. A polyamide is formed by the condensation reaction between a diamine and a dicarboxylic acid. Second example here is a reaction between dicarboxylic acid and glycol to form a polyester. Now, I am going to write the reaction for this. N molecule of your dicarboxylic acid, which can be written as R dash COOH. This is nothing but dicarboxylic acid, right? So, this dicarboxylic acid, it reacts with glycol. Your glycol molecule, I am writing it as CR. Okay, CH2, CH2, OH, OH. So, I am writing it as R twice, or you can write it as twice also. Glycol molecule. So, elimination of a simple molecule. Here, water will be getting eliminated. Water will be getting eliminated. The product formed will be N times, which is nothing but polyester. A dicarboxylic acid and diol, any diol, you can take any diol. I'm telling as glycol here. So a diol can be taken, R molecule. So diol, dicarboxylic acid, and a diol, it can be taken. Elimination of simple molecule, again water takes place here, which forms polyester. This is the second example of a condensation reaction. As you can see from the examples, high molecular weight polymers are compared to what we have in addition polymerization is formed here, and here you can see essentially that the monomer and the polymer are not the integral multiples. Whatever the polymer that is formed, it is not the integral multiple of a monomer, because there is loss of simple molecule of during this process. Therefore, there is no elimination during the process here. Now, the third type of polymerization that we are going to discuss about is copolymerization reaction. This is otherwise known as joint polymerization, and here high molecular weight polymers are formed during the reaction itself. Copolymerization has a very interesting characteristics also. Let us see this by an example of 1,3-butadiene and styrene forming SBr, styrene butadiene rubber, which is a very known example for all of us. Let us write the structure for 1,3-butadiene. 1,3-butadiene. So, buta indicates there are 4 carbon atoms here. 2, 3 and 4. So, there are 4 carbon atoms. So, it has in first and third position it has diene. So, let us put diene here. Let us fill the hydrogen here. This is 1,3-butadiene. It reacts with styrene, which we saw the structure of this styrene we saw earlier. During addition polymerization process. The product formed will be so on. CH2, single bond CH, double bond. So, earlier I thought of indicating on carbon, but you can put it like this also. So, CH2, CH, double bond, CH, single bond, CH2, single bond, CH, C6H5, single bond, CH2. So, N times. If you take N molecules of this, so indicating it correctly, you have the bonds that is shifted here, and this is shifted here, and so on. There will be shifting of the bonds here. So, 1,3-butadiene reacts with styrene to form styrene butadiene rubber. This is a copolymer, or styrene co-butadiene. You can also name it like this, a butadiene co-styrene. A polymer formed between a styrene and butadiene takes place here. So, this is your copolymerization reaction. We saw 3 types of polymerization and its characteristics with examples. One is addition, the second one is condensation, and the third one is copolymerization reaction. This is our first specific objective. We have exemplified all the 3 polymerization processes. The second is we are going to differentiate between, or we are going to compare addition and condensation based on the examples what we saw. So, the first point here is in addition and condensation, addition polymerization is otherwise known as chain polymerization, whereas condensation polymerization, it is otherwise known as step polymerization. Here, monomers having multiple bonds can undergo this type of chain polymerization, and here monomers having same or different types of functional group will undergo this type of polymerization. During polymerization, monomer add to the polymer or the bifunctional species that is formed one at a time. Therefore, you can see that the monomer unit decreases steadily throughout the reaction, whereas here what happens is any two functional groups react and they produce polymers. Therefore, monomers disappear early in the reaction itself. And here you can have high molecular weight polymers are formed immediately at once, whereas here the molecular weight increases steadily. The molecular weight of what? The molecular weight of monomer decreases, the molecular weight of polymer. Here the molecular weight of polymer, it increases steadily throughout the reaction. If there is a longer reaction time, then you will get high yield here in addition or chain growth, whereas the longer reaction time will give high molecular weight polymer in the case of condensation. Mostly all are thermoplastics which can be remolded into any shape again and again, even after it has been molded from one object, is formed by addition polymerization, because you have linear chains like this. In this. So, the linear chains here are held together by means of weak van der Waals forces. Weak forces are holding it together. Therefore, you can mold it into any shape. These are linear polymers, or linear or slightly blanched polymers are also formed in the case of addition polymerization. Whereas in the case of condensation, you mostly get network polymers or cross-linked polymers. The polymers are held together by means of what? Strong covalent forces of attraction. So, when you break this covalent forces, it cannot be again remolded into any shape. Therefore, we have a thermosetting plastics that is formed by this process. So, in addition polymerization, you form thermoplastics, whereas in condensation polymerization, most of the polymer formed are thermosetting in nature. Some examples are polyethylene, where I have indicated as PE, and vinyl chloride, and here you have bakelite, which we use in cooker handles and all, which is a phenol formaldehyde reaction. So, condensation reaction between phenol and formaldehyde, elimination of water or forms a bakelite, which is again having a highly cross-linked structure. This is one such example of condensation polymerization reaction. Now, we have seen in this class the different types of polymerization, which includes the topic 1 of your unit 3. Next class we will be discussing particularly the types of polymerization. In this type, addition polymerization reaction, where free radical polymerization, cationic and anionic mechanisms with examples will be studied in addition to Ziegler-Natta polymerization. Thank you for the session.